Hello, Algebra 2. Welcome to Chapter 5.4, and today we're going to talk about complex numbers. So before we can get into a complex number, we need to start with an imaginary number, and the need to have an imaginary number. So if I asked you to find the square root of -9, what do you think that would be? Well, there's some of you that might be thinking, well, I think that would be -3. But remember, the whole definition of square root is that you have to take a number times itself, and it's -3 times -3, -9. No, it's not. It's +9. So that wouldn't work. So it's not -3. Is it +3? Well, no, we know that 3 times 3 is 9, so it's not +3. And the whole definition of a square root is it has to be something times itself. Well, if there's nothing times itself, then we don't have a real number that we can get, so it has to be an imaginary number. So what we're going to do here is let's use our product property for radicals that we talked about last time, and we're going to split this up into the square root of -1 times the square root of 9. Okay, otherwise written, it'd be -1 times 9 under the square root. And so my product property says I can split that apart. And what is the square root of 9? Well, that just becomes 3. And we have this other part here that we are going to define. The square root of -1 is going to be I, and it's a little script I, meaning kind of a little cursive I. So that becomes I. We're going to treat it, though, more like a variable. That's a times between them. 3I. So the square root of -9 is 3I. What about the square root of -25? It's going to be 5I. And the whole thing is because when you split it up, I'm going to get a square root of 25. There's my 5. And I'm going to get a square root of -1. And there is I. So this is really important to have that part written down. Let's look at one that's not a perfect root. Right? We might have some that you have to do a little work to. Let's look at the square root of -24. So this is the square root of 24 and the square root of -1. Okay, but there's not a perfect square root of 24, so can we break down the square root of 24? Well, remember, one of those numbers needs to be a whole number. So how about 4 and 6? So that's going to give me a 2, a square root of 6, and then this over here gives me an I, and we're going to put the I for our answer. It's going to be 2I square root of 6. So that's why we need an imaginary number, so we can do these problems and then kind of how to simplify with them. Up next, we need to talk about a complex number. So standard form for a complex number is A plus BI. A is considered the real part, and then your BI is considered the imaginary part. And the thing you need to realize is a real number. This whole time we've been talking about real numbers, like 5, that is a complex number. It's a complex number that has 0 for B. So every number you've ever written is also a complex number. It's like if we were to take all the real numbers, which have the rationals and the irrationals and the whole numbers and everything else, and we put another thing around it, and these are the complex numbers. So every number we've ever talked about is also a complex number. So if we just have, let's say we have 3I, well, that's a complex number because your real part would be 0. But more so, we're going to have something here, just because we're practicing this way, that has a real part and an imaginary part. So from this, we can add these together, and essentially you're going to treat I just like a variable. It's going to have the same rules as you would have for x. So if I want to add 7i plus 5i, what's that going to be? We're going to have 12i. If I want to have 3 plus 5i plus 6 minus 4i, and the reason for the parentheses are just to show you that it's one complex number plus another complex number. So we're going to just add like terms. So we're going to add 3 and 6 are like terms. So we're going to have 9. And then 5i and negative 4i are like terms. So we're going to have plus I, or plus 1i. If by chance you are subtracting, let's say we had 2 minus 4i minus 3 plus 6i, I'm going to recommend that you distribute that minus sign, make it be negative 3 minus 6i. Still going to combine like terms. So now when we combine like terms, 2 and negative 3 make negative 1, and negative 4i and negative 6i make negative 10i. So there's adding and subtracting. We still need to talk about multiplying. So how do we multiply complex numbers? So let's start, we'll just say we have 3i times 5i. So if you were treating those like variables, multiply them together, you would get 15i squared, right? Because like x times x would be x squared. You got to add your exponents when you multiply. Well, what is the square root of negative 1 squared? It's just negative 1. So I squared, because remember that was I, that's why I used that. I squared is going to be negative 1. So you need that. Every time you see an I squared, you must replace it with negative 1. So this then becomes 15 times negative 1, which is just negative 15. So let's look at if we have 1 plus 2i times 2 minus 3i. Well, if I have a binomial times a binomial, what am I going to do? I'm going to FOIL or distribute. So first times first is going to give me 2. And then we have outside 1 times negative 3 is going to be negative 3i. And inside 2i times 2 is going to be a positive 4i. And last, 2i times negative 3i is going to be a negative 6i. And then these two middle terms were like terms, so we're going to have to combine those. Oop, and I either made a mistake or didn't say it. What did I get for last here? 2i times negative 3i, negative 6i squared. There we go. Alright, so that I squared is going to turn into a negative 1, which is actually going to turn that whole last term into a plus 6, right? Because negative 6 times negative 1. So my real part, 2 plus 6 is 8, and my imaginary part, negative 3i plus 4i, is positive I. Alright, make sure you have those key things written down. We're going to do some more examples in class on this, including division and graphing. So if you have any questions, let me know, and have a good day.